So Priya, right?
Yeah.
Okay, awesome. So today we're going to be talking about what your mom has sent me, which was to discuss Lewis dot structure and naming compounds.
Mhm.
This is what uh, uh, we'll review today, and we'll do some practice questions at the end. I had also put our at the end of this discussion, you will understand Lewis dot structure, naming compounds, and we have some practice questions. Right, so I kind of just put the periodic table here. I'm not sure like how far you've gotten in terms of like chemistry and doing understanding like the different blocks, like where metals and non-metals are in the metalloids and things like that. Um, can you give me a little bit more information in terms of like how far in chemistry you're in?
For the periodic table or
Yeah,
just in general?
like have you guys gone over the orbitals, the different
Yeah.
electron configuration?
Mhm.
Okay, awesome. All right, so this is just kind of showing that because when we're talking about Lewis dot structure, it's important to kind of know your way around the periodic table, right?
Yeah.
Right, awesome. So we know that the Lewis dot structure is just a diagram that shows the valence electrons in an element, right?
Mhm.
Right, and in the Lewis dot structure, the nucleus of the element is represented by its symbol, right? So the valence electron are represented by the dots that are placed, like you see here in the picture, right? And it's going to be around the symbol in pairs, right? And you can see, you can easily see when an element's valence shell is incompletely filled, right? Because you'll see like
Mhm.
it's kind of one of them hanging around instead of like two pairs, right?
Yeah.
Right, so you can also write Lewis dot structures for compounds, right? Like this is H2O right here, this is water, right?
Mhm.
Um, and in this case, you know that oxygen is represented by O, and oxygen wants to fill its outer shell with 8 total electrons, right?
Yeah.
Right. And if oxygen were to bond with another, you know, like in this case, hydrogen, the Lewis dot structure would look exactly like this, right?
Mhm.
Right. Okay, cool. So how do we find the Lewis dot structure of an element? Right. This is just some of like the rules, obviously, like that's why this is the periodic table is important, because within the periodic table, you need it kind of the valence electron of element coincide with the group number inside of the periodic table, right? Does that make sense?
Uh-huh.
Right? For example, let me go back to the periodic table. Like oxygen here, actually, let me move this way because this is kind of like a distribution of Lewis dot structures, right? So you can see here that oxygen is going to have, you know, this 6 valence electrons, right? Right. But the way that you
Yeah.
would write that is a little bit different because like technically oxygen has 8, right?
Mhm.
But the way that you would do that is to, let's see, screen, uh, let's see, I need a, pen. Where's the pen? Why is it doing that? Okay. Oh, here we go. So here, right, we said oxygen has its number 8 as a group, right? We see this right here, which is 8, right?
Mhm.
Right, but we said that the Lewis dot structure is 6, right? And that's mainly because the inner shell of oxygen, we have to put 2 of those electrons first, and then we can distribute the final 6, right? Because that needs to be
Yeah.
filled in with essentially then 2 more electrons, right? Because every most elements in a periodic table wants to fill its valence electron with 8 electrons, right? So in this case, you can see that there's at least 2 electrons that are not paired. And this is why where hydrogen comes in, right? Because then hydrogen can come in and bond with oxygen and help oxygen create a complete octet, right?
Okay. Yeah.
Right? I'm sure you probably already know this already, but this is the easiest way to remember it, the easiest way to do Lewis dot structures. And also, you know, if there is something more specific about Lewis dot structure that you want to review, we can do that as well. I'm just starting from the basic, you know, I don't want to make any assumption about what you know, what you don't know. And then we can build from that.
Okay.
Okay. So that's that. So pretty much you do the same thing for every element, right? You find the total valence electrons of that element. In this case, this element is nitrogen, right? And we said from this distribution of Lewis dot structure, that nitrogen has about 5, right? The electron. Right? And then you draw the skeleton just like what's happening here, right? You do N, right? 1,
Yeah.
2, 3, 4, 5, right? And then you assign the remaining valence electrons with whatever element is being partnered with. And then that will then create the essential octet, right? So oxygen, like what's happening here, right? And then, you know, initially you draw the skeleton structure using single bonds, right? Essentially, you start off with single bonds, but if there's a time when you need to make multiple bonds, you want to add that in after you placed everything, right?
Yeah.
Right, so in this case, it would be the first oxygen, which would have the second double bond here, okay? Right, does that make sense?
Yeah.
Okay, awesome. And again, the distribution of Lewis dot structure. This is kind of just baseline, right? It makes your Lewis dot structure knowledge when you just kind of remember that in every column or every column of the periodic table, you know, it's the Lewis dot distribution is kind of very constant, right? Your group 3 elements are going to have 3 valence electrons. Your group 4 elements are going to have 4 valence electrons, and so on, right? The only thing that's kind of different is when you reach helium on the right side and hydrogen on the left side, right? Right.
Yeah.
Those are the things that are kind of like exceptions within the periodic table, right? And if you also notice on the very right side on the zero group that these noble gases here are already within their octet, right?
Yeah.
Okay. And another thing that's kind of important as well, when we kind of transition to naming compounds and understanding like how do we name different, you know, whether they're ionic or molecular compounds, we have to also be able to differentiate between where the metals are in our periodic table, where the non-metals are in our periodic table, and where the metalloids are in the periodic table. Okay.
Okay.
So in this
Yeah.
case, usually the metal elements are on the left side of the periodic table, majority of them, and then the non-metals are majority on the right side. And then there's like a tiny bit of elements that are metalloid, right? And they're most likely like, this is your metal, this is your metalloid, this little tiny bit of elements on this part of the periodic table. And then the rest of this would be your non-metal, right? And then, you know, as you go, you know, also just remember, okay, we have our metals here, our non-metals here, our metalloids on the side, and then every group, you know, as we go, kind of grows with its Lewis dot diagrams and the selected numbers of elements and valence electrons associated with them.
Yeah.
Okay, makes sense?
Yeah.
All right, cool. So that's doing well. So now that we've kind of made that discussion, right, I'm gonna transition to kind of talking about naming compounds and see like how we can kind of integrate some of the stuff that we were talking about earlier into naming compounds. So again, what we were talking about earlier, that the distribution of metal, non-metals, and metalloids are important to know when it comes to naming your compounds, right? Knowing where all your metals are, right? All on the left side, all on the left side, and then your non-metals on the right side, and then the red thing is going to be your metalloids, right?
Yeah.
Okay. Okay, so when we're thinking about ionic versus non-ionic or molecular compound, right? This is also important to know because when you start naming compounds, you're either going to classify them as an ionic compound or a molecular compound. And essentially, what we're trying to say here is that within your periodic table, right? For example, ionic compound. An ionic compound is going to be made of your metal and non-metal structures, right? Or your non-metal elements, right? Which is going to be a mixture of one of the elements on the left side of your periodic table versus the right side, right? This is what we're talking about here. So an ionic compound is going to be like sodium and chloride, right? That would be what we call an ionic compound, right? Now, when we're talking about, and usually when we're talking about ionic compound, we're talking about things that are not easy to break, right? They kind of stick together very tightly, and because of that ionic compound, because the opposite attract and they're binding together, it's a little bit harder to break that bond, right? When you break bond, obviously we are forming, breaking bonds, forming energy, right? And then essentially that's going to be your high boiling point or your high melting point, which is most often kind of tested in chemistry classes, right? And then now when we're talking about molecular compounds, this is going to be molecular compounds that are made out of two nonmetals, right? Which means that they're going to come from both of them are going to come from the right side of the periodic table, right? So that's going to be your, nitrogen fluoride, right? Right? That's going to be your molecular compound. That is, a molecular is also covalent, right? That's just another name for molecular compound. Is the same thing as a covalent compound, right? So, and the thing that makes ionic and molecular two different things is the fact that with molecular, this is easier to break, right? You don't have to use that much heat or that much energy to release these bondings, okay? All right, does that make sense?
Yeah.
Okay, so now when we're naming compounds, we want to think of, we want to ask ourselves a couple of questions, right? Before we decide how we're going to name these compounds. A couple of questions is going to be like, again, back to the periodic table. Is there a metal? Is there a metal in the equation? Like, for example, NaCl here, right? For example, we ask ourselves, is there a metal? Okay, we look at our element and we're saying, okay, there is a metal. There is sodium, which I know is on the left side of the periodic table. So if your answer is a yes, then this must be, ionic, right? Is there a transition metal, right? And that means that it's asking about the middle part, right? Because we have, these are our transition metals, right? They're all in the middle. These are all of our transition metals, right? The way that we name those in combination with, a non-metal and or a metal is to use Roman numerals, right? And so we have to figure out whether the element that we're dealing with is a transition metal. And if it's not, then we say, okay, then we have to list the cation followed by an anion ending in "ide." And in the case that we're talking about right now is sodium chloride. And this, an anion is just an element that has a negative sign, right? And a cation is just an element that has a positive sign, right? So we want to use the cation first and then add that with the chloride, right? So it's going to be, and instead of just saying chlorine, we're going to use IED at the end of the compound. So we're going to say, instead of saying sodium chlorine, we're going to say sodium chloride.
Okay.
Is that simple enough?
Yeah.
So sodium chloride. I'm probably spelling this wrong, sorry, because my pen. Sodium chloride, right? So this is a sodium chloride. All right, and then if we were to have a transition metal, like if we were to have like PB, PB something, whatever element, right? PB, I would say, let's say Cl, we have to put it as lead, and then Roman numerals, and then the last full ring, right?
Mm-hmm.
Right, okay, so that's the only difference. And then moving, coming all the way back, when we ask ourselves, is there a metal? The question we want to ask is, and if the answer to that is no, then now we have to consider, is this a molecular compound, right? And if we now know that this molecular compound is, is obviously sharing two non-metal elements, then all we have to do is use the prefixes, right? And the prefixes is just like, the different, for example, carbon and oxygen, right? CO2, for example, CO2, right?
Yeah.
This is two non-metal elements, right? So this is just going to be carbon, right? And the prefix for two, right? Carbon. And then the prefix for two is just going to be di, right?
Yeah.
Dioxide, or two oxygen, right?
Mm-hmm.
Right? Okay. All right, so that's that. And then these are just kind of examples of like naming ionic and molecular compound, and the mixed kind of like a mixed list of ionic and molecular compounds. So in this case, we had calcium chloride, right, which is ionic, because it's a metal and a non-metal. And we have calcium chloride as a name, right? Then we have sulfur dioxide, because it's a molecular compound. We have two non-metal elements coming together. And then we have barium sulfate, which is ionic, right? And then we have lead chloride, which is, again, what we said earlier, if you are using an element that is a transition metal, you have to also add the Roman numerals, okay?
Yeah.
Okay, makes sense, cool. All right, so let's keep going. All right, so this is like a sheet that one of my students gave to me that he was working on. And this is like on a practice test that he did. And so this is like a topic that is definitely tested. So, and I think he retook this test after, I'm glad that we were able to kind of help him through that. He retook the test and passed it the second time. So yes, this is like a, kind of sample question, you would say, that you can possibly get, you can possibly see on the test. And you can use our slides, and I think this is what he does as well, is that when he reviews, because I send most of my students to PowerPoint after every session, is that you can kind of look through the PowerPoint and use it as a guide or a study guide to better, study for your test.
Mhm.
Okay. Okay, so practice questions. Let's see what you learned and try to do these questions.
Okay. What's the systematic name? Is that like?
Hmm?
Is the systematic name like the name? Like, I've never seen that before.
That's just the that's just like the systematic name is like with the Roman numerals, and the common name is like if it's, for example, the CuMBr is like cuprous bromide, and that's just the name, just a regular name. And the systematic name is like, okay, CuBr would be like copper bromide,
Okay. Okay, so the common name is just copper bromine, right? And then the systematic
Hmm?
copper 2 bromide.
Mm-hmm.
Okay.
Copper
The common name.
Copper 1 bromide.
Okay. And for the second one, it's just iron sulfide.
Right, or ferrous sulfide.
Yeah. And then the systematic name is it iron 4 sulfide?
Not 4.
It's going off of how many valence electrons are in, or is it the common charge of S?
Yes, the common charge of iron is in a state of what charge usually?
+2 or 3.
+2.
Okay.
I mean, it can be in 3, right, state.
Okay.
But when it is in,
yeah,
but it's in 2 state, right?
Mm-hmm.
It's usually in a comfortable state, and it's +2 state, right?
Yeah.
When it's in its +2 state, we want to use the suffix ferrous because it's the lower charge. While if it was +3 state, then it would be ferric, right? For its higher charge.
Okay.
Okay.
Uh-huh.
All right, so repeat.
I've never learned that before. Like the ferrous part.
Oh, the ferrous. I mean, that's just
Mhm.
like technicality,
Okay.
but usually people just say iron.
Okay.
Say iron sulfide, but like usually, I mean, like technicalities like ferrous, ferric. That's like the more politically correct way to say it,
Mhm.
but they don't really require you to say it like that.
Okay.
They want you to say iron, and that you recognize that it's iron, and that iron has a 2 plus form, and that it also can kind of, depending on different environmental exposure, like if too much, you can like precipitate, Fe3 plus in certain situation. So, but it usually likes to be an Fe plus and Fe2 plus, just because that's like, our blood cells have iron in them, and in the
Mhm.
Fe2 plus state, is where it's kind of like it wants to carry oxygen in that state. But whenever it is on Fe3 plus state, it doesn't want to carry oxygen. And we kind of precipitate issues in our body in terms of like oxygenation, like methemoglobinemia. Like you can induce that on somebody if you give them too much if they take too much of a certain medication. Like sometimes people that have heart disease, they can take or angina, like chest pain, they can take nitroglycerin for their angina, and sometimes it can switch the Fe2 state to a Fe3 state, kind of inducing that like methemoglobinemia, causing them not to have enough oxygen delivery to their body. But that's like a whole different discussion. This is basic, this is like basic chemistry, but like this is also good because hearing this now, it's probably going to help, you kind of, if you want to go into something like, in healthcare really in the future, this is like a way to kind of think about how chemistry is going to be, it's something that still kind of exists in the future. Yeah.
So HGO, H is silver, right?
H is it silver or what is it?
Is it gold?
Mercury.
Mercury, right? Okay.
Right.
So mercury oxide is a common name, and then the systematic name is it mercury 3 oxide?
Yeah, mercury 2.
Okay.
Right. So iron has a Fe2 and Fe3 state. Now mercury has a Fe plus 1 and a Fe plus 2 state. Okay. So that's that. So this is the answer to what we were discussing, right? Okay, now let's see the Lewis dot structures.
Okay. Isn't the first one just H and then the single bond and then H?
Yeah.
Okay.
But I actually want you to like try to write those down, answer these. I don't know if you have access to the annotating thing here.
Oh, I
can. You can like draw on the screen if you'd like.
Oh yeah. Can you see that?
Yes, I can see that.
Okay. It's probably really messy.
Okay. All I want to know is see that you're able to do it.
I think that's it for fluorine. Okay.
Hey, how did that go? Was that a lot?
I think it did okay.
Okay, so it looks like you did really well. You know this. You understand this very well. So, okay, let me just go here and let's combine answers. So you put awesome, awesome, awesome. Do I see 3 or 1 here, 2 here?
2.
Okay. It's okay. It happens. Let's see. Now there's this 2 here, supposedly. Only, right? Because it's 1, 2, 3, 4, right? Yes. So it's this and these 2 coming. Oh, I think I put too much because it's only 6. Yeah. Okay. Okay. So that's 2. And then this is correct. And then this is correct. I think that's correct. This one. And then this one. I think the only thing really is what I'm noticing is just like where to put the double bonds,
Yeah, I just didn't know how to shape it.
right? So it's like, for example, for carbon, right? We have what? 2. How many electrons does carbon have? Right, we go back to our distribution of Lewis dot structures, right? Carbon is like 4, right? So there's essentially like 1, 2, 3, 4, 1, 2, 3, 4. So this could share an electron, this could share an electron, and this could share an electron, right? And then it was acetylene, right? So this hydrogen has 1, right? Then hydrogen again has 1 on this side. So those can share an electron, and that could be a full octet, right? So that's why this is the answer to that. And then I think it was, what is this? Ethylene, right? Ethylene, 1, 2. We have 1, 2, 3, 4, 1, 2, 3, 4, right? Right. So these 2 could share an electron because there's 4. I think it's just the number of hydrogen that's different here, right? Because here, like really, there's 2 hydrogens, right? And the crazy part about all of this is like, when you relate this to the body, is that this can all happen instantly. It's literally like a switch. It could be like, so when you breathe, so sometimes when older people, they have their lungs get really more compliant, so they trap CO2 inside of their lungs. So that CO2, that means it's making their body more acidic, right? So they're like respiratory acidosis, or when someone's breathing too much, right? That means they're losing a lot of CO2, their respiratory alkalosis, and their body's acidotic, which means that they have a lot of H plus in the body, a lot of H plus in the body, a lot of H plus. And so literally you can go from like two H pluses that are just hanging out right there, that acetylene, and like automatically just go from here to here, switch like this, because of like
Mhm.
what you're breathing, whether you're not, when you're not breathing too much or when you're breathing too much. The acidity and the hydrogen like kind of concentration or management in your body changes, depending on like what status or if your body's in homeostasis. So this is like, a combination between chemistry and biology, and it's cool. When you make it make sense in a way that it applies to like life, it's easier to remember stuff like this.
Mhm.
You'll see like accumulation of like acetylene like this in like patients who are like, taking who are, what do you call it, alcoholic, taking or drinking a lot of alcohol and stuff like that. Sometimes this will accumulate, and then you can precipitate certain situation like this, or just like I was talking about with the ferrous Fe F2 state. Like those are all still, sure, you're learning this in chemistry, but like those are all very relevant to what you're learning right now.
Yeah.
It makes things easier. It makes things easier to apply when you know the basics,
Mhm.
right? Um, yes, and it even more applies to like, you know, boiling points and melting points and the breaking and the forming of the bonds, right? And to what level? Like when someone has a fever, right? When someone's temperature is high, those bonds are going to be breaking. So things are changing chemically in someone's body, and therefore the chemical structures that we're talking about. So that's the cool part about all of this. Anyway, okay, so I think again, like from my observation, it's just the double bonds kind of just like, and I think you know how to do them. I think all you have to do is kind of just sit back and a little bit and see what it's asking you, right? For this dioxygen here, right? We have
Yeah.
oxygen, obviously there's like what, valence electrons that we have to use, right? Two of them would be obviously not paired, right? Two of them would be unpaired, right? So because two of them would be unpaired, right, that means there's two of them that is able to form a double bond, right?
Yeah.
Two of them can make and so therefore there would be only two single bonds instead of three, right? So I think you're able to synthesize that. I think that you do well in these. With the other ones that you're not sure of, just sit back, breathe, and just be like, okay, I know this. So what do I have? Ask yourself the question of like, what is this? What is this really trying to want me to draw? And I do that too when I'm taking like a really high stake exams, when you have to figure out what you need to do. So this is that for that situation. That would be my advice. Just like practice the double bonds. Let's see. I'm gonna just go ahead and erase all of this. Was this helpful today at all?
Yeah.
Okay, cool. I'm glad. All right, let's see what else I have here for you. Great work. Continue to study hard. I know that you're on a break. When does school start again?
The third.
Okay. And what classes will you be taking?
Like what grade? Or
What grade? Yeah.
10th.
10th. And what classes will you be taking?
History is one of them, and then algebra 2, and then I'm also taking AP Euro and Spanish 3 and English.
English. Okay.
Mhm.
That's it. No bio, no chemistry.
No, chemistry. Taking chemistry.
And chemistry, what chemistry level? Like 1, 2, 3?
Just honors.
Hmm?
Just like honors, that's all.
Oh, okay, all right. So
Yeah.
Assuming that what will happen next is that you'll let me know, because usually, like I said, I prepare like a PowerPoint for my students so that they can have a copy of it and they can use that as a study tool when exams gets close. Um,
Mhm.
I'm assuming usually what I ask my student is to let me know what they want to review. I know that you received my email today, right? You got an email from me. You can email me on that if you want to email me like, hey, during our whenever you decide like how often we're going to be doing our tutoring sessions, you can just let me know like, hey, these are the concepts or that I want to review during our sessions, whether that's once a week or twice a week, whatever you and your mom decide. You let me know. And then in advance, I have a little bit of time right now. I'm like on a break until probably whenever you start. I almost said whenever you start medical school. Like, whenever you start school again.
Uh-huh.
Whenever you start school again. um you can, if ahead of time, if you have your syllabus already, let me know ahead of time if you have those concepts already, so I can have stuff prepared for you, PowerPoints, lectures that you can use as you kind of go into the next semester, right? And
Mhm.
obviously I know via email or your mom texting me, let me know how often you want to meet, because I know January starts in like, so this week is over, right? Next week is like a whole break, and then that's the following week.
Yeah.
Right? So there's really not a lot of time.
Uh-huh.
So this week, obviously, take your time and stuff like that, but definitely let me know. My calendar is up on the email that I sent you. There's a link there. It says Calendly, Mabel Kimball. You
Yeah, I
can
saw that.
go in there and click that and just, I want to meet on this time that I'm available. But like I said, I'm open right now up until probably that, I have a lot more time next week and the following week, like the first 2 weeks of January. So just, try to schedule some time there and let me know how often you want to meet so that I can kind of navigate between you and other students that I have as well. Um, okay, so usually before I end every session with my students after we've done practice questions, I try to get them to kind of tell me what they learned today based on our discussion. And
Mhm.
not only what you learned, but also tell me anything that you want to see more during our sessions.
Okay. I learned like the for the Lewis dot structure stuff, like you when you like did that, like when you did the examples, you did it a different way than how I was taught. And when I was watching you do it, it was easier for me to understand, like better than what my teacher taught me. So like if I use that method more, then I think I'll be a lot better with them. And
Mhm.
then for the naming compounds one, I like I know that there's like a difference between like ionic and molecular. And then I also like learned that the transition metals, those have to have those parentheses with them. And the parentheses is a common charge,
Right, the
right?
common charge,
Okay.
yes.
Is there any like renaming compounds? What if it's like two nonmetals? Is that possible?
Two nonmetals, yes, you just use the prefixes. Yeah, right. Two
Oh, okay.
nonmetals are molecular compounds, right? But then the thing is, what we didn't discuss today is like what we talked about today were just very basic, right? like very basic, one kind of elements, one element interactions. We didn't talk about like polyatomic naming, like, because there's actually like a table where, you had to name, iron with like NO3, so, and there's specific namings that are assigned to polyatomic ions. And like I said, today, we just did something that are very basic. And usually, like I said, with any new students that I have, I like to start with the basic and not make assumptions about what they know and do not know. And with that, hopefully creating not just a foundation with them, but a foundation with us.
Okay.
Right. So I'm sure you've heard of a lot of this stuff, but like you mentioned, I like to simplify things to students so that they know that this is, not as difficult as what these professors or teachers try to make it.
Yeah.
They're really not, sometimes they try to make it that way because they just want to sound smart.
Yeah.
I don't doubt that they're smart.
Uh-huh.
I don't doubt that they're smart. Sometimes some people are too smart. They don't know how to teach.
Uh-huh.
So, but these are all very, doable, simple, and it can be daunting in high school, but it's one of those things that can definitely, with practice, anything that you do, you'll be fine. Okay, is there anything that you want to see more, add more practice questions?
I would say I think more Lewis dot structure stuff.
More Lewis dot structure stuff. Yeah. And I'll probably, like, as we meet more, I'll add more layers into it. Like, we'll most likely do more of the polyatomic naming stuff. Just so you can start seeing like those, that level of naming compounds. Okay, we'll do more Lewis structure, and I'll add more like complicated ones with double bonds in them.
Okay.
Okay, thank you for that. And then and I think we're like coming up on our time here. We have 5 more minutes. So if there's anything that you specifically want to do, let me know. But at this point, what I'm going to do is I'm going to send you a copy of this PowerPoint so that you have it on you have it. Let's see. I usually put notes into them because I have notes on them that you can read so that it's helpful for you when you're reviewing. Save as a PDF. Desktop. Okay. Let's see. This is Neelam and Priya. This is Kim. And I'll just add it here. So this is the calendar. This is like my calendar. Yeah. Let's see.
So since next week is break, okay, for next one is when my school starts.
Mm-hmm.
Okay.
Sorry, say that again.
I was saying that since my next week is break and I'm not learning anything during break, is it okay if our next session is when school starts again?
Yes, it's definitely fine. It's totally fine. I'm not sure when you'll have access to stuff for school, but if you're able to send me any information during your break, we don't have to meet, but you can just send me whatever you want to review whenever we do meet. Like because like I said, just based on the calendar. So let's see. Technically, this is next week is a break and that's fine, but the following week is when school starts for you, right? So
Yeah.
we'll meet this week. I mean, not the following, not this week coming up, but the following week. But just, try to let me know whether you want to meet on a Monday evening, Wednesday evening, Friday evening, Saturday. So that will help me.
Actually,
Get
I
ready.
think my teacher already assigned new stuff. So I
Okay.
could yeah.
Yeah, so like send me, like for example, if you want to meet on, for example, you want to meet on, Wednesday night at 7 on January
Mhm.
5th. You just be like, hey, on like the next week, right? Because this week is over technically. Like this week, next week coming up, just be like, hey, these are the things I want to review during our session. I want to review polyatomic ions. I want to review, orbitals and blocks and electron configurations. These are the things that I want to look at so that,
Yeah.
I'm able to kind of, since I have time right now, I'm able to create these PowerPoints for you that you can use when you're studying for your test. Okay. I sent that, and then, yeah, we're good. It was a pleasure to meet you, and I look forward to working with you more and all that.
Yep.